Thank you for giving me opportunity to present a paper in ICEEE Conference 2023. So my title of the paper is IoT based ML model to sense selection of seed crops in changing climatic conditions of Punjab. Punjab is a state known as the greenery of India. So climatic condition here possesses a very important role in the crop yield. So Punjab soil is very fertile and favorable climatic condition, it produces the more crop yield. But now the climate changes is impact a very important role in the changes climatic conditions of Punjab. So there are very effects on the crop productivity. For example, Punjab produces wheat, rice, cotton, vegetables, etc. So there is a shift in the calendars, changes in the crop potential and the prevalence of pests and diseases under the changing climatic conditions of Punjab. And another important factor is water availability and irrigation. As you all know, some parts of the Punjab is having the scarcity of water, under which the groundwater depletion is the main factor. Irrigation practices in the region plays a very important role. So for this we developed a model in which there is a water saving technology and sustainable irrigation we can achieve with respect to the changing climatic conditions of Punjab. So our main problem formulation for this type of scenario is that there is uncertainty of changing climatic conditions in Punjab, making judgments only on basis of prior facts. As we all know, we can make judgments on the basis of the earlier facts only, and sluggish and predictive time series of data which we used earlier. So to address this problem, we are using a Markov chain Monte Carlo model in order to achieve the higher crop yield according to the changing climatic conditions of Punjab. So our main objective is we can develop a IoT based model having the Wi-Fi and a sensor using a ML model which can detect the crop yield and the crop height and all the crops which are favorable according to the climatic conditions of Punjab. How it can produce more, give the farmer the facility to able to produce more crops with this crop yield. Evaluate the accuracy and effectiveness of proposed model through extensive field trials and comparison with traditional selection models. It will provide farmers with a user-friendly interfaces and decision support tools which can actionable for optimal crop choices in the various climatic conditions of Punjab. Now here we have the system model. We can system model. Let's start from the beginning. There is a start. We can start our system having giving the inputs as a data sets which we have taken from the government dataset model. Then there is pre-processing of the model after the input. Then there are various features. Then features can be divided according to this further classification. We can divide it as yes or no. Then the methodology for this proposed model is basically having the two factors, basically, that is training and its assessment. So the data can be collected and arranged throughput according to its teaching phase, and data can be cleaned up by using the k-means clustering algorithm in which we have to cluster the data in the smaller groups. So the rules for discovering this cluster data follows a pattern mining association problem. We are also using the regression model so that it can be more useful for the future scope. Pre-processing in the first stage of the whole process, then after that it can perform step by step. So this methodology can give us more results and more accuracy for this model. So we have the Markov chain Monte Carlo model in the proposed model. So MSE is basically nothing but the mean square error which we are using, which can denote YT as the evidence from the first second up to the T time, and YT as a forecasting result in the first, second and the seventh time. Then we have a map which is not only known as the mean absolute percentage error. In YT is a real information up to the teeth period, and YT is a result of forecasting up to the teeth period. So we can using these formulas in order to calculate the accuracy and experimental results. For using the Markov chain, we can using the, so there is a possibility of the distribution according to its probability. So it can start with a 0 0 up to the Pn. If the status is finite, suppose I is equal to 0, 1, 2 or n, the transition matrix is according to that, which can having the size n plus 1 into n plus 1, where I or j value is equal to 0. So transition matrix has characteristics that is used in a Monte Carlo model. Next we have experimental results. So the experimental results depicts the status and the difference interval of difference and the likelihood scale. So having the scale greater than 100 or infinity, so there is an increase of more enormously, we can achieve a higher crop yield growth. Then in according to this chart, we have proposed a model having this labeled few intervals of time. We have labeled, means in from 70 to 100 we having increasing exceedingly, then 50 to 75 increasing aesthetically. According to, then in the next we have 25 to 50 in the scale having increased a little, 0 to 25 increase very little. Then in the negative, minus 25 to 0 there is decrease very little, minus 50 to minus 25 decrease little, then minus 75 to minus 50 decrease aesthetically, then minus 100 to D or below that there is a decrease anonymously, and last we have minus infinity to minus 100, that is decreased anonymously. That is the result we achieved from our proposed model research. So these are the analysis for the research according to the years, real and forecasting information predicted data set in different time intervals. In 2018 there is a growth chart we maintain according to the higher growth of this year. So in 2018 we have received, the blue color lines depicts the real information and the red ones depicting the results of forecasting, and the green one is MSE, that is a mean square error. So these are the result with respect to the following years we have achieved according to the crop yield and its climatic conditions. So for the year 2021 we have accuracy of data set at various time interval in its crop productivity. So red is basically the linear regression, there is a crop yield in the years with respect to its accuracy, how much accuracy we have received with respect to the various years. So in the year 2021 with our proposed approach we have received the higher accuracy, as you all see. So the conclusion for this research is study is that the emergency of Internet of Things offers a novel approach, the impact of significant change due to its climatic condition. With each generation, new seeds are developed to enhance the productivity and its unique requirements for the climatic and water. In this study, our objective was to familiarize the equipment with the crop's life cycle and provide automated guidance to farmers for maintaining optimal environmental conditions at different stages of the crop growth. So this approach aims to ensure that all critical environmental parameters are preserved throughout the crop's life cycle. We achieved 95.89% of accuracy with our proposed approach using the Markov chain Monte Carlo model. Instead of relying on a static threshold-based system, this smart agriculture project adopts a dynamic approach to cater to the evolving needs of the crop, aligning with its specific life cycle stages. By controlling the environment in accordance with the crop growth stages, the project aims to ensure that crops' dynamic demands are met. The farmer can easily identify new requirements based on the crop's development, which is closely associated with both the crop quality and its height. An equipment equipped with internet access and the sensor can perform this task easily. Thank you everyone.